Hey, all, today we're gonna stick with the right triangles, but we're gonna sort of use them in real life scenarios. It might not be scenarios you end up in ever in your life, but they're applicable. So we're gonna talk about angles of elevation and depression. An angle of elevation occurs when you look up at something. An angle of depression occurs when you look down at something. So here I have an airplane flying in the sky and a person standing on the ground. And of course, you have to use your imagination. I'm not an artist, so I just used some words. Okay, we don't have to be artists here. So suppose the plane is flying straight ahead horizontally, and the person is looking out horizontally. And then we have sort of a line that we can draw between the two. And so that when we do that, a couple angles form. If I'm in the plane, let me get a highlighter. If I'm in the plane looking straight out, and then I decide to look down towards the person on the ground, I've created an angle there, and that's called an angle of depression. It's caused by looking out horizontally and then looking down. This person, if they're standing looking towards the plane horizontally, and then they decide to look up at the plane, that's called an angle of elevation. Okay, and those words kind of jive with maybe what type of understanding you have of depression and elevation. Of course, elevation means to go up, and depression means you're kind of down or to go down, and that's how they work here in this scenario. What you might notice is that those two angles look like they're the same size, and that's because they are. We have two parallel lines. These horizontal lines are parallel. And this line between the airplane and the person is called a transversal. And these are two alternate interior angles that we already know are congruent. So if I know an angle of depression, I know the angle of elevation from the opposite side of the picture, and vice versa. If I know the angle of elevation, I know the angle of depression from the other side of the picture. And that becomes really useful because what we can do is sort of turn these pictures into right triangles. And we know how to find missing pieces in right triangles now using trigonometry. And so that's what we're going to do. It's super important for you to be drawing pictures to go with these scenarios, and then turning those pictures into problems that we've worked with already, and it'll make it a lot easier. So here we have John looking up at a tree. He's 100 feet away from the tree, and his angle of elevation to the top of the tree is 33 degrees. Now, like I said, I'm not an artist. I'm not going to try and be an artist. Some of y'all are way more creative than me, and so you can be creative here, but I'm just going to use words. I have a tall tree, and I have John standing on the ground. John is 100 feet away from the tree. That's a horizontal distance. We want to know how tall the tree is, and so I put a question mark there because we don't know it. And then we have an angle of elevation of 33 degrees. And I'm just going to keep putting the angle of elevation and depression in there, even though we don't need them both, just so you can recognize that they're the same. Okay, so if I were a bird sitting in the tree, my angle of depression looking at John would be the same as the angle of elevation, John looking at the bird. So when I drop this vertical line, I have a right triangle. And so I'm going to draw that as a right triangle now instead of a picture where this vertical piece is x, the horizontal piece is 100, and the angle down here is 33. And then I can label my opposite, my adjacent, and my hypotenuse. And so in order to find out how tall the tree is, I can use trig. I always write out my functions. Here I have my opposite side I'm looking for, my adjacent side I know, and so that means I'm going to select tangent. So the tangent of my angle of elevation 33 is equal to the opposite side x divided by the adjacent side 100. Calculate the tangent of 33. Multiply both sides by 100 to find out that that tree is close to 65 feet tall. Here's an airplane scenario now that we have some numbers. We have an airplane that's 5 miles away from the airport, and it's 2 miles above the ground. So I can draw a picture. And so I'm going to turn that into just a right triangle with my vertical is 2, horizontal is 5. And this time I'm looking for the angle of depression, which is the same as the angle of elevation, and that's why I've labeled them both. So my x is down here. So relative to this x, 2 is my opposite side, 5 is my adjacent. You might have guessed already, we're going to use tangent. It's good practice to keep writing these three functions out, though. The more you write it, the better you'll commit it to memory. So tangent of my angle x is equal to 2 over 5. I need to use an inverse function to get x by itself. So the inverse of tangent, and I forgot my little 1 right there. And so when I plug that in, I'll find out that that angle is approximately 21.8 degrees. So close to 22 degrees is my angle of depression, which is the same as my angle of elevation. So one more. I have a tall building, 50 feet high building. Somebody's standing some distance away from the building. We don't know how far, but they do know that the angle of elevation to the top of the building is 41 degrees. And so what we want to do is know how far they are from the building. So again, using my words, or you can draw a picture if you like better. I have a 50-foot high building, angle of elevation of 41, which is the same as the angle of depression. I'm just going to keep restating that. And we want to know how far away the person is from the building. So I changed that into, whoops, I changed that into a picture. Again, I happen to know the opposite side, want to know the adjacent, so we're going to use tangent again. Trust me, there'll be some that will use cosine and sine. I'll plug tangent in there, multiply both sides by x, divide both sides by 0.8693, and get that this observer standing approximately 57.5 feet away from the building. Now, just as sort of like a rule of a rule, it's not a hard and fast rule. If I have a long decimal, I tend to use 4 decimal places. The more you round, the less accurate your answer is. So if we use 4 decimal places, that's pretty good. And then you can round at the end. 57.5 is pretty good there for how far away the person is. So I have one for you to try. I want you to draw a picture, turn it into a regular right triangle, figure out which function you need to use, get as far as you can, and if you don't have a calculator, you can make your final calculation when you get to class.